Hello everybody, and welcome to today's presentation, Demystifying Microservice Testing, brought to you by Parasoft. I'd like to introduce you to our presenter. Chris Colosimo is a product manager with expertise in SDLC acceleration through automation. Chris strategizes product development and deployment of Parasoft's continuous testing solutions across major enterprises such as Capital One and Care First, working with developers and testers to discover constraints, evolve process, and facilitate the change management required to adopt Agile and DevOps principles throughout an organization.
Thanks, Ryan. Well, good morning again, everyone. Good afternoon, good evening, wherever you are. Thank you for joining today's webinar. As Ryan pointed out, we're going to be covering microservices, microservice testing. I am actually really excited about this webinar because I think that microservices represent one of the most interesting topics that everyone's talking about. So what I want to do during this webinar is go through and address some of that interest and then talk about some of the challenges associated with testing them. But before we get going on that, I'd like to actually take a couple of survey questions just so I can get a good idea of who's out there. Okay, so our first survey question is asking, I actually can't see the survey question, so I'm just going to call this out. What is your role in the organization? So what I'm looking to get from this is just to understand where it is that your role is in your organization. Are you development? Are you a tester? Are you a manager? And really what we're trying to determine here is that microservices means different things to different people. So it's going to be good to understand who our audience is today.
Okay, and so the poll results here, we have 35% developers, 26% managers, and 39% testers.
39% testers. And you said what was the percentage on developers?
35%.
Excellent. So it looks like we've got a good mix. That's good. Microservices, as we've seen in our research, is really an activity that spans across the different roles in the organization. So it's good that we're going to have different perspectives on this. All right. Well, let's go ahead and finish that one off, and then let's start the second poll question. And with this poll question, what I'm curious is, where are you with microservices? Have you started bringing it into the organization? We're starting to see it everywhere, or use it, I should say, everywhere, or our organization has decided that this is not an appropriate strategy for us. And one of the things we're going to talk about in this presentation is where some of the areas that we can benefit from microservices and where are some of the areas that we should caution the use of microservices. So it'll be interesting to see where we end up with that.
All right, and so our results are 34% not doing it, 53% starting to do it, and 13% using it everywhere.
All right, that's actually very interesting. That's so what that tells me is that there is still a little bit of mystification out there when it comes to microservices, but we do see that organizations are starting to embrace it. And I do actually appreciate that a lot of folks out there were coming forth with the not looking to do it, because there are places where it fits and places where it does not. All right, well, let's go ahead and close that off, and then we'll switch back over to me. So let's go ahead and dive into this. So what is all of this buzz around microservices? Why is it that we're seeing so much press about them? Is it marketing hype, or does it really represent the next giant leap in IT agility? And I believe that it's a combination of the two. Microservices are primarily aimed at giving us the ability to develop services that are discrete and have very specialized usage, but the principles within microservices are all around the architecture of those services. Being able to take an individual service and deploy it in its own process, using its own technology, and then provide an interface onto that microservice so that other services in our architecture can communicate with them. And when I first started hearing about this, to me, what I started thinking was, well, this sounds a lot like the principles that we have established with SOA, service-oriented service-oriented architectures and REST. And I think that what this is, microservices, is it's the next evolution of those principles. Being able to create isolated components of, with information, different services that are highly reusable is great. But now what we're seeing, especially in the era of acceleration, is that we want to be able to rapidly iterate on those individual services. And so if I have a series of services inside of my application, and I want to make a change to an individual one, microservices gives me the ability to individually deploy just that one service. So I can rapidly iterate on that one piece of information and be able to update and scale it individually. And I actually think this picture on the right, as simple as it is, paints a really good picture of what microservices represents. Our application is the box. It's a whole piece of information that we've put together with a consolidated code base, and all the different pieces talk to each other, but it's really inside of that box. Microservices says, well, let's break that box up into these individually deployable, individually scalable pieces. At the end of the day, you still have a box. Your application still does what your application did originally, but now you have the ability to independently release and independently scale these pieces. So it really is development for the accelerated era. The points of microservices were to give a business the ability to build rapidly and to test quickly individual components. Okay, so is it for everyone? Well, there's a couple things you have to consider when approaching microservices. And so we think that you should definitely embrace the use of microservices when business has decided that rapid agility and the ability to iterate over a specific component and rapidly change that and get that out to market without disrupting the application as a whole are critical business drivers. That's when you should start thinking about bringing microservice architecture into your practice. However, it's not like bacon. It doesn't just make everything better. We think organizations should caution the use of microservices when the application is relatively simple, when it doesn't have a lot of complexity to it, and business hasn't decided that rapid deployment and iteration are important drivers, because microservice architecture can add a significant level of complexity into the application, and it might not necessarily be worth the investment. All right, so let's actually talk about what makes up an architecture. And so what I wanted to do is I wanted to go through some of the common architectures that we see out there, talk a little bit about their principles, and then we'll dive into some pros and cons. So first off, regardless of the architecture that you choose, there are some core principles. Microservices should be lightweight. They should have a very specialized set of functionality or a discrete service or a very specific purpose. A microservice should be running in its own process. And that means that I can turn it on and off, I can scale it, I can change it without having to take the whole application offline. And through that, microservices should be individually deployable, and there should be a mechanism to allow us to do that. We see a lot of energy around Docker and Kubernetes that allows us to orchestrate all of that. Also, they should be individually scalable, which means that a microservice should be able to rapidly handle a large amount of load, again, without disrupting the application as a whole. Microservices, and this is one of the really exciting ones, microservices should be developed in such a way that they're using optimal technology. And what this means is that a developer, when they're first identifying how this service should work, they want to be able to choose the right type of technology to deploy that. Whether it's going to connect to, say an Oracle database or maybe a NoSQL database. Do I want to use Node.js? Do I want to use something like Python? Because each one of these services is kind of its own application. Each developer can choose the most optimal way to create and deploy this service. And finally, they should be reusable. We don't want to have to reinvent the wheel and have a whole bunch of services that are doing the same thing. That's one of the most important pieces of microservices. All right, so what do the different architectures look like? Well, we're going to contrast two very common types of architectures. The first one is orchestration. And in orchestration, processes or flows that take place through the application when invoking different microservices are predefined. We understand that this microservice is going to then call this microservice. And through that, there are explicit dependencies. Different services need each other. The communication in this type of architecture is typically synchronous, a request-response pattern. We typically see it deployed over REST HTTP. And these principles are already in practice. Again, this was that evolution of SOA. The big change in this architecture, again, being that the way that those services are deployed. And since they're already in practice, there are already some standard definitions around best practices and testing techniques, which we'll get into. Now, the new wave, or the more emergent architecture style that we're seeing is choreography, sometimes referred to as reactive or event-driven architectures. Now, in choreography, processes are a series of events that take place through the different microservices, with one microservice reacting to something that a different microservice has done. In this, there's actually a lot of decoupling. Services don't necessarily know what their dependencies on or even require those different dependencies. Communication can be asynchronous, and we see that communication takes place often using very specific message formats and protocols, such as Kafka, RabbitMQ, protocol buffers. And we're seeing these type of architectures become more and more prevalent. And we'll do some of the pros and cons and talk why we're seeing those become more prevalent. But first, let's talk about the pros and cons of the orchestration architecture. So in the bottom right-hand corner, I have a series of microservices that have a flow, and I wanted to talk through them. So in this example, you could think of if I had a banking application and I wanted to, as a part of that, have an investment portfolio. I may want to add new stocks into my portfolio. And this is the typical event flow that I might see in an application like that. When I would interact with the service that would add that stock into my portfolio, the first thing that it would do is it would call out to the accounts microservice, maybe over HTTP REST using JSON. It would check with accounts and it would look and see if I have enough funds in my account to actually add this position into my portfolio. Based on that, accounts would respond back. And portfolio would say, oh, okay, he has enough money in his account. I'm now going to call the quote service so that I can get some stock information, pricing, so on and so forth. Quotes may call an external stock service to get the actual current price of the stock. And all of these calls need to come back in sequence before portfolio can finish the job that it was assigned to do, which was adding the portfolio to my position. As you can see, this type of an architecture has a predefined flow. I know exactly which pieces get invoked. And so from one of the pros of an architecture like this is it's really easy to understand. You understand which different pieces are involved. And when it comes to debugging, you understand where particular pieces may break down and where to look. Additionally, since this has been in practice for so long, we see that these different services could be deployed using service definitions, so it's easy to understand which resources and operations are available. And these service definitions could be defined by standards like OpenAPI, which is Swagger, RAML, so on and so forth. But there's cons to architectures like this. And the first one, as you could probably already see, is that there's a central point of failure. If my account service isn't working or something breaks down, my portfolio service, when it tries to do this transaction, it's not going to be able to move forward. It can't call the quote service. And so from a testing perspective, this becomes a challenge if different microservices are unavailable or changing. And again, it's because of that tight coupling and the dependencies that become available. So let's talk about this other type of architecture, which is the reactive architecture. And I think that this type of architecture is really becoming prevalent to solve some of the challenges that we just articulated. Now, in this type of an architecture, services don't actually or necessarily communicate with each other. They communicate by publishing and subscribing to different events that are taking place as the process flows are invoked. Let me give you an example. In the same way that in my previous example, I would add a position into my stock portfolio. In a reactive environment, what the portfolio service might do is say, okay, a position was added into the portfolio. I'm simply going to transmit that and say, okay, a position was added. This position added is not actually a service, it's a queue. And you think of a queue like a bucket, and essentially a message just gets put into that bucket. And at that point, portfolio is done. It said, okay, I sent out the message, and anybody who cares to listen to that can now react to it. Well, as it turns out, accounts is interested whenever certain messages are put into the positions queue. And it says, okay, because this position was added, and because it was for this particular user, I want to go ahead and make sure that they have available funds in their account. And as a result, it also will say, hey, I reduced the amount of funds in that person's account, and I'm going to put a message into account update, and anybody that cares to listen to that can react. And any number of services can listen and can push into these event streams. And what this allows us to do is to easily add or change behavior in our architecture without having to break these different connections. And as you can see, it would be really easy to scale an architecture like that. It also allows us to come into an architecture and put in any event flow that we want, because we know we're not going to disrupt the transactions. So for our pros, as we see that these are highly scalable, there's a very loose level, or there's a decoupling due to the event streams that take place, and everybody can do their own thing. They can bend and flex this in any ways. This is also actually a con, right? Since everybody's doing their own thing, change is happening all the time. And it can be confusing and hard to debug certain event flows, because you may not know in what particular order they go. If you're not very aware or have domain knowledge of all the different interactions, it's hard to know who is listening to certain events and who will be affected by certain transaction flows. And another thing that's very interesting in reactive environments is this idea of, if the portfolio service were to put a series of messages onto, let's just say 5 different queues, and a service was going to react or pick up those messages, the order in which those messages were put onto the queue may affect how that downstream service reacts. And if those messages go out of order, it's hard to predict what that service is going to do. This is known as emergent behavior and is really hard to predict. So as we can see with some of the pros that we get, there are some cons, but really that decoupling is why we're seeing that architecture. Well, let's start talking about some of the testing challenges that get introduced with the different architectures. So as you can see, there's an increased number of dependencies. We're seeing new services show up as we start changing our application. Different types of behavior, maybe even different service contracts, become important when communicating with those different services. Additionally, parallel development causes some challenges from a testing space. If multiple developers are working on deploying different services at the same time, we don't know when that particular change may occur or how it affects the test scenario. So we need to be able to, maybe wait for the different services to become available and understand the handoffs. And this impacts the traditional methods of testing, because the tools that we have to support this type of testing may not support some of these new technologies or process flows. And most importantly, we see that there are significantly more points of failure, either due to event sequence or because of the coupling nature. But chances are, as I've been enumerating these challenges, you've probably actually been more interested in the blue ball machine that I have over on the right-hand side. And I think that this really highlights the 5th challenge. It's distracting. It's another disruption to the software delivery process, albeit a really good one and one that gives us tremendous power. But now, test basically has to approach something that looks like this blue ball machine, and they have to understand some of the different flows that take place and how are they being handed off. And so it means that they now have to learn a new technology and new techniques for approaching this challenge. Well, so this is where Parasoft can help simplify or demystify the challenges associated with microservice testing. And it's because we have a series of approaches that you can use, regardless of the architecture that you have employed, that will allow you to create a sustainable testing practice for your microservices. So let's talk about it. In an orchestrated architecture, what becomes important is making sure that you can send the right call over the right format and message protocol to a service and make sure that you get the response that comes back and validate that that information is semantically correct. And this is where Parasoft SOA Test can help us. Parasoft SOA Test is an industry-leading API testing solution that allows us to test at that invisible API layer using any type of message format or protocol. And it then allows us to validate the responses that come back and ensure that they are not only semantically correct, but they have the right data and that they are behaving the way that we would expect. And so what this allows us to do is to then test onto our individual microservices and ensure that no matter what change is taking place, we're understanding whether they are still behaving the way that they should. But one of the other things, or one of the other challenges that we may see in an architecture like this, it was the one that I highlighted because of the tight coupling. Again, in this case, if one of my services wasn't available, it's going to be really hard to test onto Portfolio. And that's where Parasoft can help, using a simulation technology through a solution called Parasoft Virtualize. Parasoft Virtualize allows us to emulate these microservices to simulate the responses that would come back from those services, regardless of the message format or protocol, and then allow you to then deploy those services into the architecture so that the event flow will always take place and you'll be able to provide predictable behavior to your test flows. And we're going to do some demonstration on these different approaches. All right, so let's now talk about how we would approach testing in a choreographed or reactive environment. So in an environment like this, it would become important that we were able to push data into our event streams and ensure that our individual services reacted to that behavior appropriately and pushed the appropriate message somewhere else. So in this case, Parasoft SOA Test allows us to simplify this process because we can communicate with a variety of microservice-specific technologies, such as Kafka, RabbitMQ, even JMS, MQ, whatever type of technology that you're using in that architecture. And SOA Test can then provide the right events at the right time to the right queues, and also consume the messages that come back from different queues. And this allows us to not only validate the flow or validate the behavior of an individual microservice, but also allows us to create stability. So in this case, if we wanted to be able to drive in specific data in a particular order to our portfolio service, but there were some other services that needed to be invoked, we could use simulation in that case to simulate the different services passing the information, or have SOA Test connect to the queue in whichever position. Regardless, this allows us to have that important isolation required to thoroughly test an individual microservice. So what I'd like to do, there's actually a third testing challenge, which is actually one of the most important challenges that we need to overcome when it comes to testing microservices. And that is, with all of these different changes that are taking place and all of the different pieces that may be moving, it's important to us to build a testing practice that allows us to validate two important things. First, we need to understand the impact of change between two specific components. If there's a relationship or a service definition that's describing a particular type of message that needs to be sent, we need to understand if that has changed in any way and have a remediation path to update any test artifacts that we've created. Additionally, we want to be able to understand from an environment level if services are changing. In microservice transformations, what we see often is that what once was one service will end up turning into 5, 6, 7 different microservices. And being able to pinpoint the actual services that would be affected by that change, and again, have a path to remediate that is important. And Parasoft can help us do both of those things. First, by providing a map between different service definitions so that we can understand the different pieces that have changed, and also from a holistic environment perspective by understanding which services are connected to each other. All right, so let's go ahead and dive into some practical examples. So what I'm going to do is I would like to walk through 2 typical testing scenarios that we would see in the different architectures. The first one I'm going to do is an orchestrated example. I'm going to make some calls into a scenario that has a series of connected components. I want to validate that the request that I send in, elicits the proper behavior, and as well as being able to stabilize that environment through simulation. And then I'm going to jump into an event-driven architecture, and I want to be able to drive data into a Kafka data stream, validate that my service behaves the way that it should, and pick up those events in a subsequent queue. And I'm going to focus on 4 specific things: testing an orchestrated microservice architecture, stabilization with virtualization or a simulation, and then using the same techniques to test an event-driven architecture. And then, most importantly, I want to be able to understand the overall coverage that I've achieved from the different types of testing. So what I'm going to do is I'm going to dive into the Parasoft ecosystem. And what we're looking at here is our Parasoft continuous testing platform, which is a workspace or an interface onto the library of test cases that we have, as well as different virtual services. This allows us to coordinate our testing activities as it relates to the environment. And this actually is the first piece that becomes important to us. So here inside of my ecosystem, I have diagrammed out one of my banking architectures, which is actually a hybrid architecture. Hybrid architectures take advantage of both orchestrated and reactive services. In this architecture, I have a couple of different event flows that are represented in different environments. One, which is an orchestrated flow, and another one, which is reactive. So in this architecture, what I can do is I can actually go to the specific event flow in the environment where I have the different services. And what you'll see is that I actually have this diagram providing some value to me. It's telling me, which different pieces are involved and what their current configuration is. In this case, what I want to do is I want to execute a series of REST-based test cases against my application flow. Now go ahead and ignore those little red exclamation marks. They are going to become important in just a second. So let me dive down into this. And what I'm going to do is I'm going to simply execute some tests. What you'll notice is that as a part of this architecture, I've actually connected a series of tests as well as a series of services on the back end. Right now, I'm just using all the real services in my environment. So I'm going to go ahead and provision, which means go ahead and make the necessary environmental changes to run this test, and then run your test scenario. Okay. So what we see in this case is that testing onto this flow, I've had some kind of a failure. So let's take a deeper look and figure out what's going on here. So here are my test results that have come back from SOA test, and I have a series of requirements that those are tied to, but let me collapse that for now. What we can see is that I made a series of REST-based calls using a service definition against the different services in all of my different microservices. And one of them actually has failed, and it looks like I'm getting some kind of internal server error. And I could look into the traffic that was associated with that. But let's come back to those exclamation marks for a second. In the Parasoft environment that I had produced, I actually already knew that information, because one of the things that the continuous testing platform allows us to do is to do health checks on the individual services through our test cases or through simply checking at a service endpoint. And if I had actually checked those exclamation marks ahead of time, I would have found out, uh-oh, I actually can't run this scenario because one of my microservices is currently offline. Now, this gives me the ability to actually go to the development team and in a meaningful way say, hey, I'm getting test results that are indicating in this particular environment that this microservice is offline. But I need to be able to continue my testing. And so that's where service virtualization, or the ability to simulate different components, becomes important in this type of testing. What I have created ahead of time was a simulated representation of this microservice that would respond just like the real microservice would. What I can do in this architecture is choose a configuration where I'm using a virtual service at that endpoint. And I don't actually have to bump the environment guys to do this. I can simply re-provision this environment, and Parasoft will take care of the rest. So Parasoft will actually turn on that virtual service and will reconfigure a connection so that we are now pointing at the virtual service instead of the live service. It then reruns the test scenario, and this time, that looks a lot better. I can come into these test results and I can say, okay, great. My 18 out of my 18 tests passed. It looks like the different microservices in my scenario are behaving appropriately. There is a potential problem with loan being offline, but me and test, I can execute in one track while development can do something in parallel. Neither of us are blocked. And so it helps us, achieve this problem of, environmental outages and all of the things that come from change that microservices bring. But there's actually something else that's quite interesting in this report, and that is my API coverage. Now, microservices are all about being able to create individual building blocks that are isolated from each other, and they'll interface with each other using these APIs. One of the things that becomes really important for me is validating that I'm completely testing the breadth of a particular API and all of the resources and services that it provides. And Parasoft allows me to understand all of the different services and resources that were available to me, as well as understanding those services that I didn't test. And while I have a problem with my loan processor microservice, this is actually considerably riskier to me because I see that there are a series of resources that I'm not even testing. And so this allows me an easy mechanism to then go in, understand the tests that I've created for those services, and then repurpose them for other service transactions. Okay, so that gives us the ability to not only test at the API level onto any service in our architecture, but also gives us the ability to rapidly deploy simulation to stabilize and support our test environment, as well as being able to provide any type of data that we need for either activity, either driving in any type of data for both the test and validation of a service, or providing that data for the simulated service. Okay. Well, let's jump into the second type of architecture, the reactive architecture, choreography. And so I think a good way to articulate this one is to go back into my environment diagram and show this reactive stream. So essentially, this is very similar to the example that I was talking about earlier. In this case, for my online banking application, I want to be able to add different stocks into my portfolio. And as I add these stocks into my portfolio, I want to be able to understand what's my current portfolio position, what different symbols are in there, and what's the average, minimum, and maximum. So I've actually created a microservice that allows me to do that, and I've put a little UI on top of it. So this is just a UI for demonstration purposes, but essentially what I can do is I can add different symbols to my portfolio. For example, let's Amazon, and maybe Google. I'll go ahead and add those guys in there. And then what we'll see is that these start getting fed in data for the current stock price. Now, for everyone out there, just understand these are fictitious numbers, so don't go racing to check your portfolio. These are all coming from my test environment. But what you'll see is that what my actual application is doing is that based on the different values that are coming into the portfolio's event stream, it's figuring out what the minimum values are, what the maximum values are, and then what the average value is. And that's really what my service does. And so I want to be able to continue working on my service and developing new functionality into it. But one of the challenges that I have is being able to provide predictable data into my flow and then validate that the data or the result of that service is what I expect. And since these data values are constantly changing, this is difficult for me. So again, let me just go back to this real quick and go into my reactive service. So again, what's happening is that the stock data is coming into this queue, this Kafka queue. This service is deployed via Kafka. Sorry, it's communicating via Kafka. My service is picking that up, doing its math, and then posting that somewhere else for my investment service to pick up. Okay. So I can easily take control of this testing challenge and both provide meaningful data values as well as provide the ability to isolate that individual component. And I can do that using Parasoft SOA test. Now, in this case, I've gone under the hood a little bit because I want to show you some of the connection information for Kafka, because it is very specific to that technology. So what I have set up here is a test case using the same techniques that I would create any of my other types of testing, whether it's API, mobile, performance. In this particular case, though, what I'm doing is I'm communicating over the Kafka protocol. And SOA test has the ability to act as both a consumer and a producer, supplying any data value that I want into my stream, and then picking that data back up in a meaningful way so that we can validate it. And so what I'm going to do is I'm going to go ahead and stop the changing data from coming into my service. And now what I can do is I can create a stable environment for testing, feed my own data in, and then validate that data. So the first thing I'm going to do is I'm going to actually communicate to the system via Kafka to just clean up after itself. Okay, and that just lets me clear everything out. This is a great part of being able to test with setup tests through SOA test, because you can set all sorts of preconditions regardless of whether it's a database or a Kafka queue or a web functional test, and say, stabilize my test environment. Okay. Now what I'm going to do is I'm going to go ahead and communicate to the service and say, add 2 positions. All right, so now it's going to go ahead and put that message onto the stream. I'm going to see that my service picks those positions up. And now what I'm going to do is I'm going to provide some predictable data to it. A stock price of 100, a stock price of 50, and then a stock price of 25. And I should see coming out of this that my minimum should be 25, my maximum should be 100, and my average is 58.33. Okay, basic math. But this has been really hard to do with that data that was streaming into the event queue. Now I can look at this and I can say, okay, it's 58.33, but I want to be able to automate this testing. So what I've done in my last test is I have actually provided an assertion. In this case, it's JSON, but it could be any type of response that comes back. And for this particular configuration, I've added an assertion that says, when you get this payload, from the service, validate that this particular element has the expected value of 58.33. And this really makes the validation process really simple, because I can add all sorts of different meaningful assertions without having to write any scripts. Things like, string contains, does not contains, greater than, less than, has structure, so on and so forth. And it really allows me to target very specific behavior from my microservices, again, without having to write any script. And because I have the ability to clean up after myself, I can simply run this test over and over as a part of my continuous testing strategy and constantly validate that that information comes back as I expect. And if it doesn't, like I put in here, then I get meaningful information into my system. And I intentionally put this error in there just to highlight that this test could run over and over and over again and only alert me if something happens with my service changing. And so through that, it allows us to support different types of testing in microservice architectures, whether you're doing orchestration or reactive services. You can test your orchestrated services using API service definitions, as well as data driving the different assertions that you have. And you can stabilize those test environments using simulation. So you have the right test environment at the right time. In those choreographed or reactive architectures, you can use Parasoft's wide array of message formats and protocols to be able to easily drive in data and consume different data values as they come out of the system, which allows you to both validate your microservices as well as to provide isolation. And most importantly, you have the ability to understand API coverage so that you can understand which test artifacts may need to be migrated, which virtual services may need to be updated, and you can understand which services are actually getting invoked as a part of your test case, which gives you much greater understanding of your level of risk. Okay, so that's about it. I think now we can dive into Q&A. So let me look at this box real quick. Okay, cool. Lots of questions. Okay, so I'm actually just going to start at the top here and start diving through these. So we have a question here that's asking, how do we distinguish between a web service and a microservice? This is a really good question. And so one of the interesting pieces about microservices, which I articulated at the beginning, was that since they're an evolution of SOA, a microservice is really all about how it's deployed. And you know, a web service and a microservice may be interfaced the same way via a REST API, but a microservice would be deployed in its own process. So for a testing perspective, being able to test on a web service and a microservice, kind of the same thing. What becomes important, though, is being able to isolate and understand the different interactions. All right, so we have another question here that's saying, why should communication between the services be asynchronous? Okay, so I think one of the interesting pieces of those choreographed architectures is that they really focus on decoupling. And so it's not necessarily so important that we focus on its asynchronous, but that there's reduced dependencies. And that services have a way of being able to operate without necessarily requiring other microservices to be available. Asynchronicity is just one way that we can provide this type of architecture because you fire off the event and it doesn't really matter whether something comes back. But I think that's why you see in some of those architectures that's the method of conveyance that's ultimately chosen. All right, let's see. Okay, so well, will Parasoft support testing of microservices using Kafka messaging system? Yeah. So we actually have a whole series of message formats and protocols that we've added into the solution to support microservice testing. Kafka, RabbitMQ. We've also added protocol buffers as a message format. Parasoft SOA test actually has over 120 supported message formats and protocols. Everything ranging from simple SOAP, SOAP XML, all the way to ISO 8583, fixed, Swift, EDI. So really what it is it's about being able to make sure that you have the right message format for the right type of testing that you're doing. And that's one of the things that we focus on with the solution is having that support ahead of time. Is there any business process change with microservice implementation? Good question. So business from a business perspective, the things that I have been noticing with talking to the different customers is that originally business was really focused on being able to get product to market faster. And they were seeing that they were able to accelerate that through techniques like, build automation, automated delivery systems, DevOps, so on and so forth. What they were doing was they were releasing artifacts to market at a very fast rate, but there were a lot of defects in them. And I've actually seen business now refocusing on quality. And so what they're really interested in is being able to put, a process in place where they're continuously validating or continuously testing all of these different components as they work their way through, because being first to market isn't necessarily as important as being not having defects that are leaking in production, and so on and so forth. So I think that from a business perspective, there are a series of things that the organization needs to focus on. For microservices specifically, there should be a testing strategy in place, and then an understanding of which components need to be iterated on and released quickly. What else do we have? Can we get a report or an email when a real service or virtual service is not available or down? Yeah. So what the question is asking here is, inside of that dashboard that I showed you, where we had the different services being architected, if there was a service that was down, could we get a notification for that? And absolutely, that dashboard can be provisioned or configured programmatically, either as a part of VSTS, Jenkins, TeamCity, Bamboo, what have you, or by simply making a REST API call to that. And from that, you can understand which services are up, which services are down, and you can accomplish that by creating those meaningful health checks that tell you the different endpoints. We actually have some good information about that on the forums. There's quite a few questions here. Let me look at time real quick. Okay, great. Is accounts microservice mocked as well for orchestration scenario? Let me look at that real quick. I forgot which one. Right. So typically, what we see organizations do is they will create virtual services for the different communication that takes place between a test and its different dependencies, and they'll have those virtual services in waiting. And for the majority of the time, they'll just run against the live services, but then use the continuous testing platform to allow us to automatically switch over to the virtual representation. In my particular example, I did not create a virtual representation for accounts, but it would have been really easy for me to do so by simply recording the communication that took place between retail and accounts, and then creating a virtual service and simply supplying it here. In this case, it's using real accounts. I think that's the question you were asking. There's no live virtual marker. Also, we got some good questions about integration tests. Let's see if we can wrap these into one question. How do we prepare for the integration data sets? How do we check coverage of integration testing? So for integration testing, the idea would be that we want to make sure that when we bring this microservice into the actual system where all the other services are represented, we want to be able to have a complete testing strategy for not only testing that my microservice behaves the way that I expect, but also that the communication between the two microservices behaves the way that I expect. And we can do that in two different ways. One, you can actually make discrete calls to each of the individual microservices and bring that into a comprehensive health check or a test case, and then reference the different pieces that appear inside of the ecosystem. Or you can use the same technology that you use to monitor the transactions that take place between the different services, and see that as the different calls start working their way down the line, that you're getting that feedback into your test into your SOA test library, and validating that when the different services call each other, that both their requests and responses are appropriate. We have a couple of different technologies that allow us to do that, and it's all built into the tool. What was the second question that was asked there? Sorry, I'm getting a lot of questions, and I think that one flew up towards the top there. Oh, yeah. How do we check the coverage of an integration test? So if each one, so as I was saying before, if we were validating that each one of the individual microservices had its own set of API tests, just like retail and loan, and each one of these had its own API service definition, then SOA test will automatically, if you've created that test from that service definition, tell you your API coverage as it makes those individual calls. Because what it looks at is these individual resources were defined by this service definition, and whether it was whether it came from two test steps that were connected to each other or two test steps in the same scenario, it doesn't really matter. It aggregates all that information together and says, these were all the tests that you did against this service. These are all the tests that you did against that service. Okay. Oh, there's some really good questions here. Where can we find that mapping version comparison that was in one of your slides earlier? Okay, so what's being referred to here is Parasoft's Change Advisor. Parasoft's Change Advisor allows us to understand the difference between two different versions of a service contract. Where you would find that is it's right there inside of the Parasoft SOA test tool. And actually, as a part of that same testing strategy where you were creating your test with the service contract and then validating your API coverage, you could actually, what you actually could then do is start loading those APIs into, those service contracts into a library that associates them with the individual test case, so that as you get different versions of them, you can either manually go and map them against each other, or we have something called change impact analysis, which as a function of simply running a test case, will do that comparison and say, well, based on my current definition of the service contract, has anything changed? And if it has, it gives you meaningful information about what's changed, as well as a path to mitigate that change. Okay, do you have an extensible app architecture that allows custom message protocols, i.e. not industry standard, to be leveraged? And absolutely, the answer is absolutely yes. So there's two answers to this. And the first thing I'm going to do is actually go to marketplace.parasoft.com. And what marketplace.parasoft.com represents is think of it like an app store where our developers and some of our clients have helped us to build different custom tool extensions, message formats, protocols, different data sets, so on and so forth. And they do a lot of this using our extensibility API. We have a very rich API that allows you to, yes, build your own message formats and protocols, as well as being able to, build in different functionality for the test cases and so on and so forth. And then you can either host them then internally and federate them out to the different testers, or maybe submit them to us and we can harden them and make them available. But yes, whether it's a industry standard or a proprietary protocol, absolutely you can do that. Let's see here. Providers are developing at the same time. In an environment where a consumer and a service provider are developing at the same time, can Parasoft generate a test from an open API or Swagger 3.0 spec? And how would that work? How would the parallel development work? Couple of answers to that. So the first one is that both test cases and virtual services can be generated from Open API, any version of Swagger, previous version of Swagger, WSDL, RAML, and a series of other service definitions. And what that will allow you to do is to create a virtual representation of that API, as well as a test case that tests that API. And then the two developers that are developing against each other can simply swap artifacts. And the developer who has a dependency can say, hey, I'm not ready yet. I haven't finished my service, but here's a simulation. Here's a virtual representation of what my service is going to do. You can go ahead and continue your development and just hit my virtual service, and it will give you what the response will be like. And that unblocks them, and vice versa. If you're developing a service and there's a service to which you have a dependency, you can have them create a test case, or so you can create the test case using the service definition and say, okay, this is how they're going to consume me. And you can continuously run that test case against the service that you're developing to ensure that the interaction between the two of you is going to work. So it's a combination of testing and virtual services. Really good question. Thank you for asking that. So there's actually a couple of questions here, and we're kind of coming up on time, but I want to try to get them in here. I'm seeing a couple questions around performance testing. So I'm going to answer that in two different ways. From an API testing from API testing's perspective, Parasoft has the ability to take any API test that you've created against your microservice and run that at load and at speed, leveraging Parasoft's load test solution. And what this allows you to do is a couple of different things. One, take those API tests in their specific the way that you've created them, as well as with any of those custom message formats and protocols, and to be able to then validate an individual microservice. So if let's say you're continuing to develop a microservice and you want to make sure that the technology that you're using is optimal, you could run this performance test on your microservice as a function of code check-in, and then you could watch the trending information that we provide to show you whether your performance is starting to degrade. At the same time, you can leverage service virtualization and build in performance characteristics to each individual virtual service and show them what that behavior would be as an aggregate to the entire ecosystem. And I think that's actually all that we have time for today. Thank you everybody for the questions. We'll answer a lot of them offline. For more information, go ahead and head over to parasoft.com/microservices. And there's also some handouts that are available for you to continue your education. All right, thank you everyone.